back in the day, I used to work on embedded devices and also known as Internet of Things. Mostly these devices were safety critical in nature. The product development for these devices pose very unique challenges, like the underlying hardware keeps changing at a very rapid pace in this industry, and lots of these devices are required for real-time response and are safety critical in nature, which means that human life can be endangered if this product malfunctions. For instance, if a Tesla car malfunctions, human lives are endangered. Finally, lots of these, since they are programmed on embedded devices or microprocessors, they have very limited memory and processing capability compared to what a regular desktop or laptop would have. So all of these things create very unique challenges for writing firmware for these products. The concept of encapsulation is one of the ways to cope with these challenges. Usually you would have a driver layer which is interacting with the underlying hardware, the microprocessor and all the peripherals on it. So you would have a wrapper above that, and any of the service layer for the program we are writing would interact with that wrapper layer rather than the drivers themselves. So in this video, we'll talk about some problems that Internet of Things systems face and how encapsulation helps them, and importantly, how we can translate that encapsulation concept in our automation projects, and how would that help our framework or automation framework design. Elaborating further on the problems that you might at an embedded device or an Internet of Things device would see these days. Firstly, it takes a lot of effort to develop software or firmware for these devices. Any software that's written for microprocessors is usually called firmware. So firmware for these devices, for instance, there was a gas sensor that I worked on, and we just needed to add safety compliance for that firmware, and with just some refactoring to add that safety feature set there and documentation around it and testing that, it took us 2 man years. So you can imagine the effort that goes into developing these devices, and that was just one gas sensor. So it takes a lot of effort. Also, the change of hardware is very fast in this industry. The memory and hardware and processing power that these devices carry are very limited, and day by day we are having powerful microprocessors being introduced. Also, the industry or the environment in which these devices operate is changing very quickly, so there are business needs as well which are driving requirements or needs for change. So with all of this, and these devices these systems taking a lot of time to develop in the first place, you can see the challenge there. And when we do have a hardware change, these devices, if you are not careful, you would have to rewrite everything. Compare that with something for instance, a SaaS application that you might have. What kind of software upgrade would you need if you would change your server machine from let's say 4 cores to 8 cores, for instance? There is hardly any change there. But for these devices, if you change the microprocessor from one which has X memory to which has 2X memory, it's just a new processor. You would have to rewrite everything. So one of the solutions to this problem is using encapsulation, and the way that works is you would usually have an application layer at the very top, then you would have a service layer, and then finally you would have a driver layer, and this driver layer is communicating with your microprocessor. So instead of this service layer communicating with the driver layer directly, you would have a wrapper on top of this, and the service layer is now communicating with the wrapper layer, which is indirectly getting information from the driver layer. This encapsulation provides the portability. If you would change the underlying hardware, probably you would have to definitely rewrite the driver part, but service layer and above, probably not. You could save that, and that's the main purpose for doing that, for adding a wrapper layer on top of your driver layer. This also adds a lot of maintainability advantages. You would it's easy if you would add new peripherals to the driver part, or you would remove any hardware. So again, this encapsulation makes sure that there's not a lot of change that has to be done on the upper layers. And also you can isolate problems to a specific layer. For instance, if there's some communication issue on a specific communication protocol, let's say if you're using Bluetooth somewhere, you can isolate the problem if it's on the driver layer or if it's on the service layer. That adds debugging ease over there as well. In terms of reusability, since again the service layer, everything has to talk with the wrapper layer, and this is exposed to everyone, so each function here in this wrapper layer is pretty much designed to be reusable. So there's a lot of reusability that the above layers can get from this wrapper layer. And that's a very important concept and very important aspect for IoT or embedded devices, because again, as I said, there's hardware limitations, so you would not want to write long or lengthy software or firmware for that. It has to be concise. We talked about portability, so if you do change the hardware or add peripherals, that can be done easily. So a lot of benefits around adding this wrapper layer or encapsulation for IoT devices specifically, but more importantly, this concept can be used very effectively for automation projects as well, and let's see how we can do that. So, but how does this automation or encapsulation help automation projects? So the driver or the reason for having encapsulation for IoT or embedded devices was a lot of change, and there's a lot of cost associated to updating. Again, in automation, the cost of updating and maintenance cost is that's a significant cost again, and also the change which we are seeing now for automation is everything in automation underlying is changing. Your application under test is changing. The browser versions, if you're doing web applications, the browser keeps changing, and if you're using in the most case you would be using multiple browsers to test on: Chrome, Mozilla, IE, Edge, Safari. They keep on sending new versions. For each version, for instance, there might be with your application version 17 and the Chrome version 62, there was a problem. With 63 it works fine, then Chrome upgrades to 64, again there's a problem. So there's a lot of change in terms of what our application or our UI automation is interacting with. The tool might also change. For instance, the automation tool you are using, if you are using a vendor based tool, a newer version came in, something was working in the previous version, they just probably might deprecate it in the new version, or probably if there's a new driver in the newer version and it's not working, it's not suiting your specific tests well, all of that can happen. We've seen that. Testing requirements can change. You might be moving on to continuous integration, you might be adding API level tests, you might need to move some of the functionality away from UI to different layers. That's also a lot of change. So all of these factors add up to a lot of change that's going on, and that's one of the reasons why automation is getting harder and harder day by day, because there's a lot of change going on. So that's kind of where I thought that this concept of IoTs, or Internet of Things encapsulation or wrapper layers would be very beneficial for automation projects. And this might not be a very flashy new concept which hasn't been talked about before. It's a very common concept, but adding perspective to how it's being done in different industries and how it might affect automation, I believe that would bring a new dynamic to how we look at encapsulation and having a wrapper layer. So let's talk about how you would do that. So I generally first, before I begin, the concept or discussion about having a layered architecture would be a rather lengthy one, so I won't be going into completely how you would divide your complete application into layers, but just the at least the service layer or the driver layer or common routines layer, or you could call it pretty much anything, which is the criteria we usually use in our team is that anything that is communicating with an outside our automation project is a separate layer, which you can call let's call it the service layer. So you're sending text to the browser, that's a service layer thing. You are closing the browser, instantiating or starting the browser, or anything interacting with the browser, sending a get request, sending a post request, all of that would be a service layer function. The actual function which is communicating with anything outside our automation project is what we consider a service layer application, and that complete layer has to be separate. First off, I'm hoping that it is separate in your project. That's a must. So it should be separate, and not just separate, it should have a wrapper on top of it. So what do we mean by a wrapper? For instance, if we are using so there's a function that you have written for writing text to a certain to a text field, for instance, let's say. You could use the direct function of your underlying tool directly wherever you are writing text, but instead of doing that, I would encourage you write a separate function which is supposed to write text, and within that function, for instance, it can be called my text write, and within my text write you are calling the underlying tools text write function, even if it's just one call and there's nothing else before or after you are writing that text. I highly recommend you do add something before or after, but even if you aren't, there should be a separate function. And the benefit of that is, eventually at any given point, if you want to change this function which you are using to write text, you can just change this, and the top function called my text write is what you have used all over. That does not, you don't have to change that, and with just that change you can the whole project gets changed, and that's a very powerful concept. Little bit on the layers. So you would have this wrapper or service layer which is wrapped around your functions. So the service layer, and within that the wrapper layer, and within that the service layer. On top of it you might have the POM if you are using page object models, and on top of it you might have your test cases and then use cases, and just keeping in mind reusability, how you can create these layers to be reusable. So the whole benefit and other benefits for this change would be, again, if there's a tool change, if you want to use a new function change. In many cases we didn't use the tool function. In some cases we used direct JavaScript somewhere and to write values, or to deal with browser alerts and whatnot. So you can do that, and it's just that you change just your service layer one function and it gets changed everywhere. The final thing, benefit which I see very important with this approach is portability. Unfortunately, there's with all the changes that we just discussed earlier, there's this final urge for us automation engineers to keep on changing tools, or requirements come from up. If you go back like a few years, they were just probably back in 2005 we had just big vendor based tools probably that were more common. Then Selenium came in, then approaches over Selenium came in, then TDD, BDD came in, and now we are moving on to different concepts. So, and whenever these new concepts come in, there's for some reason this notion of you need to switch to what's the latest shiny thing. And I've seen cases where people are switching over to BDD even if it's not, they're not using the real benefit of why BDD is used for communication. They're not using it, but it's just being used as an automation tool. So if you do decide to change tools or frameworks underlying over the years, having this portability, having this wrapper tool around your underlying functions would be very, very beneficial, and it would be very easy to port your project from one tool or one framework or architecture to another, because then you have this isolation and anything above your service layer can remain intact, and anything below or within your service layer you can change that, and for the most part you might be good to go. So just to recapture our discussion, we talked about what is encapsulation and how is it used in embedded or IoT devices, and what's the benefit that it provides to embedded devices, and how can we build this concept in our automation projects, and what benefits our automation projects would see if we add this encapsulation or wrapper layer. I hope this video was useful for you. Thank you for watching, and if you like this, do not forget to subscribe and join us in the movement of redefining software quality. Thank you. Talk to you next time.